Welcome, everyone, to Module 1 of Quantitative Analysis for Management Decision. In this module, we're going to lay the foundation for everything that will follow in the rest of the course. I want you to think of this as the groundwork, just like building a house. Before you can build walls or install the roof, you need a solid base. Here, that base is your understanding of what quantitative analysis actually is, why it matters, and how it's applied in the real world of management. Our journey today will take us through definitions, basic principles, types of data, decision-making frameworks, descriptive statistics, probability, sampling methods, and the role of data collection. These concepts are not just theoretical, they are the bread and butter of every manager, executive, and analyst who needs to make decisions that are informed, rational, and defensible. 1.1 Introduction to Quantitative Analysis. Let's begin with a simple question. What is quantitative analysis? Quantitative analysis is the process of using numerical data and mathematical models to understand situations, evaluate options, and make decisions. It's the opposite of purely intuitive decision-making. Instead of relying only on gut feelings, we lean on data, structured methods, and logical reasoning. Now, you might be thinking, does this mean that managers never rely on intuition? Not at all. In fact, some of the best decision-makers combine both intuition and quantitative insights. But without numbers, without measurements, it becomes almost impossible to explain or justify decisions to others, investors, stakeholders, regulators, or even your own team. A good way to think about quantitative analysis is this. It transforms raw facts into structured knowledge that can guide action. Imagine you run a hotel chain and want to know whether to open a new branch in another city. You could just feel it's a good idea, but quantitative analysis lets you examine occupancy rates, average daily revenue, cost projections, competitor pricing, and local tourism trends before making that investment. 1.2 Why quantitative analysis matters in management decision-making. So, why is this so important for managers? Let's go through a few reasons. Objectivity. The decisions supported by data are less likely to be biased or based on personal preference. Risk reduction. By analyzing data, you can anticipate possible risks and create strategies to mitigate them. Resource optimization. Whether it's money, time, or personnel, quantitative analysis helps you allocate resources where they will have the most impact. Measurability. If you can track results and evaluate whether decisions have achieved their intended goals. Predictive capability. With proper data, you can forecast trends and prepare for the future. Think about companies like Amazon or Netflix. Their recommendations, pricing, inventory management, and marketing strategies are built on complex quantitative analysis. Without it, they would be operating in the dark. 1.3 The role of the manager in quantitative decision-making. A manager's role is not necessarily to perform all the calculations themselves, although having that skill is valuable, but to understand the analysis being presented, interpret the results correctly, ask the right questions about the assumptions behind the numbers, integrate quantitative insights with qualitative factors such as company culture, customer perception, and ethical considerations. For example, a financial analysis might show that cutting 15% of the workforce would boost profitability in the short term. But a good manager also weighs the long-term effects, employee morale, public image, and the risk of losing valuable talent. 1.4 Key concepts in quantitative analysis. Before we dive deeper, let's define a few key concepts you'll hear repeatedly throughout the course. Data, raw facts and figures. They are the building blocks of analysis. Information, data that has been processed, organized, or structured in a way that makes it meaningful. Model, a simplified representation of reality, often in mathematical or logical form, used to analyze situations and test scenarios. Decision variables, the controllable inputs in a decision-making problem. Constraints, limitations or restrictions on possible choices, such as budget, time, or regulatory requirements. Objective function, the goal you're trying to achieve, such as maximizing profit or minimizing cost. 1.5 The decision-making process. Every management decision, whether it's about launching a new product, entering a new market, or hiring new staff, follows a general process. Quantitative analysis fits into this process by providing the tools for informed evaluation. The typical decision-making steps are: define the problem. Clarity here is critical. A poorly defined problem leads to poor decisions. For example, sales are low is vague. A better problem statement might be: sales in the West Coast region have declined by 15% over the last 2 quarters despite increased advertising expenditure. Identify decision criteria. These are the standards by which you will evaluate options, such as cost, time to implement, expected return, or alignment with company strategy. Assign weights to criteria. Some criteria matter more than others. For example, speed of implementation might be more important than cost in an emergency. Develop alternatives. Come up with a list of possible actions. The more alternatives you have, the more options you can test. Analyze alternatives. This is where quantitative analysis really comes in, comparing options based on measurable data. Choose the best alternative. Select the option that best meets your objectives within the given constraints. Implement the decision. Execution matters just as much as analysis. Evaluate the decision. After implementation, measure results against expectations. 1.6 Types of data in quantitative analysis. Not all data is the same, and the type of data you're working with affects the analysis methods you use. Qualitative data, descriptive, non-numerical information, such as customer opinions. Quantitative data, numerical information, such as sales figures or production cost. Quantitative data can be further classified into discrete data, countable values, like the number of employees. Continuous data, measurable values within a range, like weight or temperature. 1.7 Levels of measurement. Understanding the level of measurement is essential because it determines which statistical techniques are appropriate. Nominal, data that names or labels categories without order. Example, department names. Ordinal, data with a ranked order, but no consistent interval. Example, customer satisfaction ratings. Interval, data with ordered categories and equal intervals, but no true zero. Example, temperature in Celsius. Ratio, data with ordered categories, equal intervals, and a true zero. Example, revenue, weight. 1.8 Descriptive statistics. Descriptive statistics summarize and present data in a meaningful way. Key measures include mean, average. Median, middle value. Mode, most frequent value. Range. Variance. Standard deviation. For example, knowing that your company's average monthly sales are $50,000 is useful, but knowing that the standard deviation is $15,000 tells you how much fluctuation you have month to month. 1.9 Probability and its role in decision-making. Probability measures the likelihood of events occurring. In management, this is crucial for forecasting and risk assessment. For example, the probability that a shipment arrives late. The probability that a marketing campaign increases sales by at least 10%. Managers use probability to weigh options under uncertainty, because most real-world decisions are made without knowing the future with certainty. 1.10 Data collection and sampling. Reliable analysis depends on good data. Poor data leads to poor decisions, the classic garbage in, garbage out problem. Data collection methods include surveys, interviews, observations, company records, market reports. When it's not possible to collect data from the entire population, managers use sampling, selecting a subset that represents the whole. Common sampling methods. Simple random sampling. Stratified sampling. Cluster sampling. Systematic sampling. 1.11 Wrapping up Module 1. In this module, we've covered what quantitative analysis is and why it's important, the decision-making process, types of data and levels of measurement, descriptive statistics basics, the role of probability, data collection and sampling methods. Everything we've discussed forms the toolkit that you, as a manager, will use to approach problems logically and make decisions that are both data-driven and strategically sound. In Module 2, we'll take these foundations and build upon them, moving into more advanced topics like model building, optimization, simulation, forecasting, and applying quantitative analysis to real-world business scenarios.